Welcome to 100% here. Today, in composite material and structures, we are going to discuss the topic fiber volume ratio, mass fraction, and elastic constants in the composite materials. Actually, these fiber volume ratio, mass fraction, and elastic constants are very important parameters in composite materials. In this, we are going to discuss fiber volume ratio and mainly focused on what this one, as well as mass fraction, elastic constants. Then I have a relationship between the fiber volume ratio and mass fraction, elastic constant, as well as the importance in composite materials. These things we are going to discuss. Let's start with the fiber volume ratio. Actually, it is defined as the ratio of the volume of fibers to the volume of the composites. Generally, the composite is nothing but the mass of fibers plus mass of the matrix. So fibers and matrix put together, it is called as the composite. So that it is given as the ratio of the volume of fibers to the total volume of the composites. And this fiber volume ratio affects the mechanical properties of composite, such as stiffness and strength are being affected by the fiber volume ratio. Typically, it ranges from 0.3 to 0.7 for most of the composite materials. Then we can go for the mass fraction. It is also defined as the ratio of mass of fibers to the mass total mass of the composite. So here mass fraction, we are concentrating on the fibers. So mass of fibers to the total mass of composite. So we are concentrating on mass. Then related to the fiber volume ratio, it takes into account the density of the fibers and the matrix also, because the density and the volume, mass and volume both are having the relationship. So density equal to mass by volume. So when we are going for a mass, we can compare it to the density also. Okay, so related to the fiber volume ratio, but it takes into account density of the fibers to the matrix. It also affects the mechanical properties in the composite, such as the stiffness and strength. Then you can move on to the elastic constants. So we all know that the relationship between the stress and the strain in the material. Like Hooke's law, what we earlier studied about Hooke's law, stress is directly proportional to strain within the elastic limit. So within the elastic limit only this Hooke's law is applicable. If we go beyond that elastic limit, this Hooke's law will not be applicable because it is not a linear state, it will be non-linear state. Then you can go for when you are testing a tensile test, after elastic limit, it will go for the yield limit, then ultimate limit, then you can go for the fraction. So when we are dealing with this elastic constants, up to elastic limit only we have to concentrate. So including the Young's modulus as well as Poisson ratio and shear modulus, that is EGK, EG as well as Poisson ratio is new lateral dimension to the original dimension. The ratio is called Poisson's ratio. It also affects the mechanical behavior of the composite. Same thing, strength, the stiffness, as well as the toughness. Toughness is the mechanical property which gives the resistance for material to failure. Sorry, then what is the relationship between fiber volume ratio, then mass fraction, elastic constant? These things just we can go for a glance. So fiber volume ratio, mass fraction are related through the density of the fibers and the matrix. Fiber volume ratio as well as the mass fraction are related through the density of the fibers and the matrix. But elastic constants are affected by this mass fraction as well as the fiber volume ratio, as well as the properties of the individual constituents. Accurate prediction of the elastic constants requires knowledge of fiber volume ratio as well as mass fraction and constituents of the properties. So the relations between these fiber volume ratio as well as mass fraction and elastic constants are focused on these three things only. Then what are the importance of this fiber volume ratio, mass fraction as elastic constant in composite materials? These also to be focused. So fiber volume ratio, mass fraction and elastic constants are critical in designing and optimizing the composite structures. So they are very critical in designing and optimizing the composite structures, as well as it affect the mechanical performance, weight, and the cost of the composite materials also. They are used in various industries such as aerospace, automotive, and the energy sectors also. So by understanding the relationship between the fiber volume ratio, mass fraction, and elastic constants, we can design and optimize the composite materials for specific applications. Then, elaborately, we can discuss the fiber volume ratio. It told the ratio between the volume of fibers to the total volume of the fibers. Fiber volume ratio affects the mechanical properties of the composite, such as the stiffness, strength, and toughness. The range of the fiber volume ratio is 0.3 to 0.7 for most of the composite materials. And what are the factors affecting this fiber volume ratio? They are fiber packing efficiency. The first one is fiber packing efficiency. Then fiber diameter and the fiber length also will be affected. Then matrix, material, and properties. These three are the very important factors that affect the fiber volume ratio. Then mass fraction, as we discussed the ratio between the mass of fibers to the total mass of the composite. And the importance of the mass fraction is affecting the mechanical properties. It affects the mechanical properties of the composites, like stiffness, strength, and toughness, as well as the relationship with the fiber volume ratio. Mass fraction is related to the fiber volume ratio through the density of the fibers and matrix. I told you the relation between the density, mass, and volume, because the density equal to mass by volume only, but density does not change. And due to the mass fraction as well as the fiber volume ratio, it may affect the factors like fiber density, matrix density, and fiber volume ratio. Next, we move on to the elastic constants. The constants that define relationship between the stress and the strain in the material. That is the elastic constants. Generally, elastic constants are Young's modulus, Poisson's ratio, and shear modulus. Generally, we studied in the strength modulus as Poisson, bulk modulus as the elastic constant. In composite materials, we are not going to study about the bulk modulus because we are going to focus only a little bit element. So X modulus will come and the shear modulus will come, and Poisson's ratio, because lateral dimension change due to applications of the load in the length of axial directions. So Poisson's ratio we have to concentrate in the elastic constants types. Then what are the factors affecting the elastic constants? That should be very important. Same thing, fiber volume ratio. Definitely it affects the elastic constants, as well as mass fraction is also affecting the elastic constants. Then properties of individual constituents. That's nothing but the fibers and the matrix. These individually it will affect the elastic constants. Then what are the relationship between the fiber volume ratio, mass fraction, and elastic constants? Fiber volume ratio and mass fractions are related through the density of the fibers and the matrix. The elastic constants are affected by fiber volume ratio and the mass fractions as well as the properties of individual constituents. So accurate prediction of the elastic constant requires the knowledge of fiber volume ratio as well as mass fraction and constituents of the properties. The importance of composite materials for mass fraction, fiber volume ratio, and elastic constants. And focusing on these things, what is the importance in composite materials? Generally, they are critical items in designing as well as the optimizing the composite proper structures and affect the mechanical performance as well as the weight and the cost of the composite materials. And they are very much used in the aerospace industries, automotive industries, as well as the energy sectors. So the mathematical expression is given by having that discussion with respect to the definitions as well as the relations between the fiber volume ratio, mass fractions, and elastic constant, and how it deals with the elastic properties and the densities. The relations are given, you just notify those things. So by understanding the relationship between the fiber volume ratio, mass fraction, and elastic constants, we can design and optimize the composite materials for specific applications, leading to improved mechanical performance as well as the reduced weight and lower costs. So these are all things in today's class we have discussed. Once again, I just recall. One is the fiber volume ratio, what is the definition, and what is the importance, what are the ranges in the composite materials, and how it affects the properties of mechanical properties of the composite materials, like that mass fractions also, and elastic constants. What is the relationship between the fiber volume ratio, then mass fraction, and the elastic constants? How it affects? What are the factors being affected through these three parameters? And what are the main importance in the composite materials by considering these three things? So those things we have considered. So that's all in this class. Then we will have another topic in the next class.